You know, for years, the TV show Westworld gave us this incredible and, let's be honest, pretty terrifying vision of how you could build lifelike androids. It always felt like pure science fiction, right? Well, what if I told you that future is showing up way faster than we thought, and from a place nobody saw coming?
And look, that's not just some catchy headline. There's a new manufacturing breakthrough that is so revolutionary, it's kind of spooky how much it looks like the methods from the show. Real-world tech is catching up, and that line between sci-fi and reality, it is getting blurrier every single day.
Okay, so to really get how big of a leap this is, we gotta go back to the blueprint that fired up everyone's imagination in the first place. Let's start with Westworld's vision for creating its hosts.
The show was brilliant because it didn't just have these perfect robots appear out of nowhere. No, it showed us the factory floor. The production team actually based the whole fabrication process on real emerging tech like 3D bioprinting to make it feel totally grounded. And the result was this vision of androids being built layer by layer in one smooth, seamless, automated process. This slide just lays it all out perfectly. On the left, you've got Westworld's elegant, continuous process. And on the right, that's our current reality. Building a robot today means sitting there and painstakingly screwing together hundreds, sometimes thousands of individual parts. It's ridiculously complex, it's slow, and every single one of those little parts is a potential point of failure.
But, you know, that messy reality, it hasn't slowed anyone down. In fact, it's kicked off a full-blown global race to build the first true general-purpose humanoids. And this is where our story pivots from fiction to a really high-stakes competition.
We are in the middle of what you could call a global humanoid frenzy right now. And the big players, especially in the US and China, they are not being subtle about their inspiration. They've totally embraced that slick, futuristic Westworld look, using it in their branding to basically scream, hey, we're building the future here.
And believe me, the field is getting crowded. Over in China, you've got companies like X-Robots pushing for that hyper-realistic look, while XPeng is all about bio-inspired mechanics, stuff like artificial muscles. Meanwhile, over here in the West, you have clone robotics using super advanced 3D printing to copy human anatomy. Everybody's chasing the same dream, just taking slightly different roads to get there.
So you've got all this money, all this brain power, focused on the US and China. But the real game changer, the innovation that actually solves that core manufacturing problem we talked about, well, it came from somewhere completely off the radar.
So take a guess. Where do you think it came from? Some secret lab in Silicon Valley? A massive state-funded project in Beijing? Nope. The real answer is probably going to surprise you.
Get this, Budapest, Hungary. A little startup called Alanic, founded just back in 2021. They looked at the old way of assembling robots piece by piece and basically said, this is a dead end. It's too slow, it's way too expensive, and it's holding the entire industry back.
So they invented something called the 3D tissue braiding system. Now, hang on, this isn't 3D printing, which builds things one layer at a time. This is more like weaving. In one single continuous go, it grades a robot's entire mechanical body. We're talking structural fibers, tendons, even the electrical wiring, all at once, right around a simple frame.
Honestly, the best way to get your head around it is this quote. It's a system that's closer to making clothing than industrial machinery. It's a textile approach to robotics. You're creating a complete integrated system instead of just bolting a bunch of metal parts together. It's a whole new ballgame.
And the process itself is just beautifully simple. You start with a basic skeletal scaffold. Then the machine does its magic, braiding everything else around it. The strong fibers, the stretchy materials for movement, all the tendons and cables, and boom, what comes out the other end is a body that's mechanically complete and ready to be turned on.
And yeah, people with deep pockets are paying attention. Alanic just pulled in $7.2 million in a pre-seed funding round, which is the largest in Hungary's history. Look, when investors who are tied to giants like OpenAI and Hugging Face get involved, you know you're looking at something that is about to change everything.
Okay, so this brings us to the final piece of the puzzle. Why is this weaving technology such a huge deal right now? Because it's basically the key that's about to unlock the next generation of humanoid robots.
Alanic's timing here is just perfect. The whole robotics industry is in the middle of this massive pivot. They're moving away from those heavy, rigid, kind of dangerous industrial machines and toward these lighter, more flexible, tendon-driven designs. These new robots are way safer to have around people, and they're a whole lot more energy efficient.
I mean, just take a look at 1X's Neo. This thing is incredibly light, just 66 pounds, but it can lift more than twice its own body weight. That's insane.
These new, super-efficient, tendon-based designs are the exact kind of robot that Alanic's braiding process is built to create.
So, when you boil it all down, 3D tissue braiding solves the biggest headaches in robotics manufacturing. It radically simplifies production, slashes the part count, and gets rid of all those failure points. It makes these new, lighter, stronger designs possible. And most importantly, it's built to scale, from one little hand all the way up to a full humanoid body.
So we started this whole thing with Westworld, a piece of science fiction, and we've ended up with a real technology that brings its manufacturing process to life. But we have to remember, the show was always meant to be a cautionary tale, right? About consciousness and control. So the final question is, now that we actually have the tools to build that future, are we even listening to the warning?